All right, guys. So far we've learned pretty much everything that we need to graph the typical rational function. Now, at the end, we'll talk a little bit about a special case where you have oblique asymptotes. But in general, you usually have just horizontal and vertical asymptotes. Trying to think. Oh, missing parentheses here. Sorry. I'll fix that. I'll fix that before I release the notes to you guys. Okay, so here's the 6 steps to graphing a rational function. First of all, find intercepts, which is something that we've seen time and time again, right? In particular, what's most important is finding the x-intercepts. And we know the x-intercepts are just the zeros of the polynomial, or the rational function, yeah? Okay, number 2, we're gonna find vertical asymptotes. We spent, first video about talking about that. And then find the horizontal asymptotes, and if they exist, or the oblique asymptotes. I'll talk about those in the next section in a little bit, if they exist. And then not lastly, but number 4, check for symmetry. This step to me is kind of optional. I think you could get by without checking for symmetry, but it is nice to know. That way you know if you should just be graphing directly symmetric over either the x or y axis. Mostly over the x-axis, if you like. Also over the y-axis, I mean, or if you have something that's symmetric over the y-axis, like x squared, right? Or something like, could be something like this, that kind of thing. Or the other type of symmetry is the odd symmetry, which is basically symmetry across the origin, where you rotate 180 degrees, right? But like I said, I think that now is less important because you can kind of get the rough shape even without knowing for sure if there's symmetry or not. Okay, number 5, determine whether the graph is above or below the horizontal / oblique asymptotes. And the way to go about this, I think, or at least one simple way, is to just utilize test points. So what kind of happens is, like, your graphing thing, right? You start with your, let me just draw the x-axis and y-axis first. So say you have the graph, right? And then you kind of start by figuring out, okay, where you crossing the x-axis. And then you figure out maybe some asymptotes you might have. Let's say you had like a couple asymptotes, right? Okay, and then you figure out, okay, you have a horizontal asymptote some spot. And what you want to know is if there's any spot where you cross the horizontal asymptote. So to know if you cross the horizontal asymptote, you just look at the original function and note whatever this value is at the horizontal asymptote, is your function ever equal to that? If it is, then you cross to that point, right? And then after that, you just try to check, okay, you look at your vertical asymptotes, and you look at in between each one, where are you relative to the horizontal asymptote? Are you above? In this case, if you have like cross and you already know you're above, then you can kind of know which way you're gonna approach the asymptote, something like this. In this case, you're above, right? And then maybe you could cross either like this. So you want to know if you're gonna be above or below at different spots. So you can just plug in points to check. And then something here. Say it crosses, and you can get a picture of where your graph is headed. Okay, and then lastly, once you know all those things, then you just sketch the graph. Okay, it's helpful to kind of think about also the approach to the vertical asymptotes, whether you're going to be going up or down or whatever. Okay, before we get into sketching the graphs, let's talk about the last topic, which is oblique asymptote. So oblique asymptote, if you notice the way I have this little box here, it's very akin to the way that we talked about the horizontal asymptotes, right? And that's on purpose because, typically you either have a horizontal asymptote or an oblique asymptote. You can't have both of them. And oblique asymptotes occur specifically when you have this certain thing happening with the numerator degree and denominator degree. And that is when the numerator degree is exactly 1 more than the denominator degree. So it's greater than the numerator degree is greater than the denominator degree by exactly 1. And that difference of 1 degree means it's a difference basically of a linear function. So when you divide, the quotient would be some linear function. Linear function just meaning the equation of some line, right? So if you're to plot that line, plot the quotient, then that will give you an oblique asymptote. Oblique just means it's not vertical, it's not horizontal, but it's kind of diagonal. It hits it at a slant. Could be something like that or something like this. Could be going up or down. I mean, like slope positive or negative. Yeah, okay. So just to recap, yeah, when you have the numerator degrees less than the denominator degree, that means you're going to get a horizontal asymptote y equal to 0. When they're equal, you get the horizontal asymptote at the quotient of their leading coefficients. And if the top is 1 degree higher than the bottom, then you get this oblique asymptote happening. Okay, let's try the questions. So we have 8 remaining questions. 1, 2, 3, 4, 5, 6, 7, 8. And we've got, this is the third video. So the plan is to do 4 of these graphs in this one, and then 4 in the next video. Okay, so that's the plan. But you know how these things go. Hopefully we'll finish on time. And if I feel like it's going too long, then we'll quit early and maybe split into third video. Okay, starting with number 10. So find the asymptotes, intercepts, and then graph. Those are basic instructions. But basically we're gonna roughly follow the 6 steps in our 6-step process to graphing. Yeah, this thing, roughly speaking. But we'll kind of play it by ear. So number 10, we at least have to do this. We at least have to find the asymptotes, intercepts, and the graph. So first of all, what I like to do is just rewrite this thing in its factored form if it's possible. So this is x plus 1. And actually, this is already factored. It's actually already factored. So x plus 1 squared, if you want to just rewrite it out, that's x plus 1, right? And right now, we have what's called, this is not a removable discontinuity because this is simplified already. And so what we have is a vertical asymptote at x equal to -1, right? Now we also have a horizontal asymptote because the top degree is lower than the bottom degree. And so we have horizontal asymptote at y equal to 0. Remember, if the dominated degree is higher than the top degree, that means as x gets really, really big, then your overall thing is going to go to 0. So you have horizontal asymptote at y equal to 0. That's your x. And this is your y. Okay, so let's plot our asymptotes to start. Vertical asymptote at -1. So here's -1 somewhere over here. Okay, I'm going to plot that asymptote. And then I have a horizontal asymptote at 0. That's this guy right here, right along the x-axis. Okay, so this is a simple case. There's only a few things that could happen, right? So I could be up here, or I could be down here when I'm on the left side of the what you call it, vertical asymptote. And on the right side, I could be up here or down here. Okay, now next thing I want to know is what are the intercepts? Yeah, what are the intercepts? Well, okay, what's going to make this 0 on the top? What's going to make f of x equal to 0? So I say, okay, what is there a solution to this? -1 over x plus 1, x plus 1. Is there a possible solution where this y is equal to 0? And the answer is no, right? Because that would mean the numerator would have to be 0, but the numerator is only -1 always. So that means there's no intercepts. There's no x-intercepts, I mean. Now, there will be a y-intercept, right? So that happens when x is equal to 0. So what about the y-intercept? That's when x equals to 0, right? So here, that would be if I just plug in 0 for x, that would be -1 over 2, -1/2. So -f. And this is useful to know here because, okay, here's -1, -1/2 would be here. So I have the y-intercept right there. And that puts me below the horizontal asymptote, right? So for that case, I know where I lie in reference to the horizontal asymptote. Now, the other thing we need to check is, do I ever cross the horizontal asymptote? And I kind of checked just now already because the horizontal asymptote is at y equal to 0. So if I wanted to check, I plug in that for y, right? Or plug in, f of x equal to 0. And then check, but that's actually the same question as whether or not there's a x-intercept. And the answer is no, right? Never crosses. There's no solution to that equation. Because look, you could even just finish solving this. How would you solve this? You multiply both sides by the denominator, but when you multiply this left side by 0, you're gonna get 0. So you get 0 equal to -1, which is not possible. So there's no solution. So I got an equation with no solution to it, right? Okay, so now I'm all set to graph. That means my graph, I know on the bottom, I'm here at the bottom below because this point indicates where I should be, right? So I'm up here, down here, and approaching that, and then hit that, and then approach the horizontal asymptote, but never touch it. So I know I'm down below there. Now, my guess is this is going to probably be something like that, but actually, no, maybe not. I take it back. I think actually it's more like this probably, just based on the fact that this is squared on the bottom. But what we'll do is we'll check a test point. So this was -1 for x, right? So what I'm going to do is just plug in -2 for x and see, am I up here or down there? Okay, so what I mean is that I'm going to check f of -2. That's -1 over -2 plus 1, -2 plus 1. That's -1 over -2 plus 1 is -1 times -2 plus 1 is -1, which is -1 over -1 times -1 is +1, right? So it's going to be overall -1. So look what happened. At -2, x equals to -2, I'm at -1. So that means I'm at this point right here. Right? So also negative, which means, oh, okay. My graph should have hit that point, and then I should approach the horizontal asymptote. Something like that. Yeah? Okay, nice. Now, if you want to check, a good way to check is just to try using the Desmos graphing calculator engine just after you've already finished sketching it, just to check your work. And just plug the thing in. Or, well, I guess you're doing it with me, so in this particular case, you can just watch my video and check that way. So I guess you've already checked it. But if if you don't have that luxury, if you don't have, if you're doing a question where you're not following along with me doing a video, then an easy way to check is just to plug it into the Desmos graphing calculator and then just see it there. Or there's other ones too. Another good resource, I've never mentioned this before, but there's something called Wolfram Alpha. This is actually a big deal back when I was a high school student. It's still going strong. Wolfram Alpha. Wolfram, I think I spelled it wrong. It's called Wolfram Alpha. Look it up online. They can like solve equations. They give you step-by-step instructions. They also show you graphs. It's pretty great. All right, number 11, guys. Number 11. Number 11, just look at it at face value. This is looking like, okay, it's going to have a similar horizontal asymptote. And maybe look roughly like 1 over x. That kind of thing, but maybe with a shift or something. Let's see. That's just my face value intuition. But, we're going to work it out. Let's see. I'm going to write it just with y instead. Just it's easier for me to think of it as a graph that way. Okay, and we're going to start by finding asymptotes. So this guy, we're going to factor out, right? That's -x over x squared minus 1 is x plus 1, x minus 1. Okay, great. So I've got vertical asymptotes at x equal to 1 and x equal to -1. I've got a horizontal asymptote. Notice the degree in the top is lower than the degree in the bottom. So horizontal asymptote again at y equal to 0. Okay, while we're at it, why don't we just find the x and y intercepts? So x intercepts, this is when y equal to 0, right? So that's going to be 0 equal to -x over x plus 1, x minus 1. Now multiplying both sides by this denominator, I get 0 equal to -x. So x must have been equal to 0. Easy. So that means the point 0, 0 is a x-intercept. And it also gives me the y-intercept because that's when x is 0, that means y equals 0, right? They're partnered together. Because I just found out that when y is equal to 0, x is also equal to 0. So that means when x is 0, y is also 0. So that's easy. This is probably we know so far. Starting with the asymptotes. Asymptotes are at +1 here. And then -1 here. Okay, and then also horizontal asymptote at y equal to 0. So that's right along this here. Yeah. Okay. And then let's also plot our point. Oh, okay. Interesting happens. Where here, look, we do cross the horizontal asymptote. And easy case here, because the horizontal asymptote is at 0, then the cross happens right there at our point of intersecting the x-axis as well, right? That happens one time. There's only one solution to that equation. Okay, that's great. So what's looking like to me is probably going to happen. Okay, we're either going to be above or below over there on the left, above or below here on the right. And then here, my guess is it's going to do something like this or something like that. I'm not sure which. But how do we know which one? Well, there's a couple ways you could do this. You could just kind of think of what's going to happen as you approach this -1 or +1 from either side. Is it going to be positive or negative? And in this case, positive or negative is enough because that's going to tell you whether you're above or below this horizontal asymptote, right? Okay, another option is to just use test points. Just use test points. So what's a good test point? Well, this is 0, 0. This is -1. This is +1, right? So an obvious test point for me would be -2 and +2, and then -0.5, and then +0.5. Okay, so those are the spots I want to check to see what is going on in my function in terms of the horizontal asymptote. So what was my original reduced function? I'm going to do that in blue down here. So it's y equal to negative x over x plus 1, x minus 1, right? Okay, so let's go back to function notation. That'll make more sense with plugging the number in. At negative 2, f of negative 2, I'm going to have negative of negative 2 over negative 2 plus 1. I know I'm not following my own recommendation here. I know I always recommend that you guys include that x value in its own parentheses. So, yeah, I should probably do that. Okay, so that's negative 2. That means it's positive 2 on the top. Negative 2 plus 1 is negative 1. And negative 2 minus 1 is negative 3, which is 2 over 1 times 3. Negative 1 times negative 3 is positive 3. So the point here, though, is that just thing is positive. Yeah, 2/3 is positive. So negative 2 is 2/3. That's above the x-axis, which means my graph, and I know it doesn't cross the horizontal asymptote again, so it's got to approach it. And then that means if I'm going to approach this vertical asymptote, since I'm not going to cross, it's got to go up. It's got to go up that way. So overall, it should look something like this. Okay. The next time I do this, I'm going to do the same thing. I'm going to do another check with positive 2 this time. And when I do this check, I'm not going to actually even bother doing the whole calculation. All I care about is whether it's positive or negative. So if I plug in 2, this part up here is going to be negative, right? It's negative 2. If I plug in 2 down here, that's going to be positive. 2 minus 1 positive. So negative over something positive, overall is going to be negative. So all I care about here, I don't care about the actual number that pops out. I just care about the fact that at positive 2, this is going to be less than 0. It's negative. So when I go to do my graph, I'm going to be down here somewhere. This is kind of in the way. I'm down here somewhere, negative. So I should be below. That means my graph looks something like this. Okay, now I'm doing the same thing for these two spots, yeah? And just check positive or negative again. Right, so let's change colors just to indicate that I'm doing something different now. I don't like green though. Let's try purple. Okay, so here I have f of a half. Let's do half first. Okay, and then this one would be negative, right? So I got something negative. A half over here, that would be something positive. And half here would be half minus 1 is something negative. So negative over positive times negative overall is positive. So that's overall going to be something positive. That means that a half, I'm over here somewhere, yeah? Positive. Okay, I'm just going to put a temporary marker over there, indicate that I'm somewhere positive. And then let's check negative a half now. So let's redo the same kind of thing, both negative a half. So negative a half. So if I take negative of negative a half, that's going to be something positive now. Negative half plus 1, still positive, and negative half minus 1, that's negative. So we've got positive, positive, negative, overall that's negative. So now this guy is in my way. So let me just plot it. So now it's negative. When I plug in negative half in something negative, right? Something like this. So that kind of goes along with my intuition. It does cross through the x-axis. That means as I approach this asymptote on the left, it should be going down, and then cross through, and then hit that point, and then start going up. Right, so here's my graph, something like this. Okay, just let's take a look at this one since we graphed it, and let's see what happened if I compare this to the Desmos version. So negative x over x squared minus 1. Negative x over. Wait. There we go. Negative x. The bottom is x squared minus 1. Okay, it's a moment of truth. Let's see. Oh yeah, see. Looks just like mine, right? Let's graph our asymptotes too. X equal to negative 1. See that? And then x equal to positive 1. Look at that. See? So see how this green graph approaches that asymptote as you go down, it's going down. See, it's getting closer and closer. It looks, if I zoom out, it looks like it touches, but it's actually not touching. It's just getting closer and closer to the asymptote. And then, yeah, it's in all the positions that I said it should be in, right? So, sweet. Just confirmed that we got the right picture there. Okay. I'm not going to do that for everyone. I just kind of randomly picked that one to do it. This video, like I said, we're going to do 2 more. At least that's the plan. And then we'll call it quits until the next one. Boom. Okay. All right, here we go. Number 12. Number 12. Okay, looking at this thing, I get the same power on top and bottom. So that means I'm expecting to have a horizontal asymptote at the quotient of those two coefficients. Yeah. But let's work it out. So let me write it up here. I'm going to write it as y equals to x squared over x squared plus 1. No, x squared plus 1, it's not factorable. So it is at lowest terms already. Also note, in this case, there is no vertical asymptote, right? Because there's no value of x that's going to make the denominator 0 there. So, okay, no vertical asymptote. Okay, what about horizontal asymptote? Yes, there is one. And this one is at the quotient of the leading coefficients. In this case, this is really just 1x squared over 1x squared plus 1. So this is going to be a leading coefficient of 1 over 1, right? So y equal to 1 over 1, or in other words, just 1. This is your horizontal asymptote. Okay, interesting. Let's go graph this thing. Oh, I forgot. X and y intercept. Yeah. So let's do the x-intercept first. And actually, we're going to be doing them at the same time again, looks like. Because when y equal to 0, I've got 0 equal to x squared over x squared plus 1. Multiply both sides by x squared plus 1. I get 0 equal to x squared. So x squared is equal to 0. X is equal to 0. So that means 0, 0 is my x-intercept. Which also means if I plug in 0, I'm going to get that same intercept, 0, 0. Okay? So I've got that point that I know. And then let's graph now our horizontal asymptote. Horizontal asymptote at y equal to 1, right? So let's look at this. Okay, I know I crossed the x-axis at that point. Now the other thing I want to know is where am I positive or negative? So it looks like Okay. So this is also the other thing to get a good picture of what's happening is I'd like to kind of know what is the end behavior of this graph, because I don't know where I should be going here. My intuition tells me I should be approaching this horizontal asymptote as I go left and right. But let's just think about it for a second. And what I want to think about is what happens as x goes to negative infinity here. Because I don't have the vertical asymptotes to guide me this time. So I kind of left a little bit with less information. So I need to just kind of figure out my bearings of where I'm going. As x goes to negative infinity, think about this function up here. This thing on the top is going to get really big. This thing on the bottom is going to get really, really big. But both of those values, the one is going to become negligible, right? And so it's going to really just depend upon these two x squareds, those two x squared terms. And since they're the same, as x gets really big, it's just going to head towards that horizontal asymptote. And that's true whether I'm looking at negative infinity or positive infinity, either way. So in both cases, I should be approaching that asymptote as I head out to the far left or far right. That makes me think, okay, it should be going somewhere like this, right? My graph should be something like that. And then it should hit that guy right there. And I know I can't cross again, so probably it should look something like this. It should be smooth, but it should be approaching both sides. But let's also check, what else do I need to check? I think that's pretty much it, right? Okay, so I got the asymptotes, got the intercepts. Yeah, next thing left is just to graph. So I know it should approach this horizontal asymptote on both sides. It should hit that intercept in the middle. But otherwise, I want to have like a smooth curve. So boom, something like that. That's what I'm thinking. Okay, let's check what the actual graph should look like. Okay, so I'm going to check out the Desmos one. X squared over x squared plus 1. This is x squared. Oops, squared. This on the bottom. So x squared plus 1. And look at that, guys. Look at that. Just like we predicted, yeah? And here, let me plot the horizontal asymptote at the same time. Y equal to 1. And I know it looks like it's touching, yeah? But if you just zoom in close, it's not actually touching. It's just getting closer and closer. Forever, yeah? So, and then right there, where it touches, and then goes back up. Okay, sweet. Okay, that was 12. Down. One more to go. Another one where the numerator and denominator have the same degree. So I have the same similar type of horizontal asymptote that we were talking about before, where you just divide the leading coefficients. And then the bottom this time should be factored. So let's look at this. So this is 13. I've got y equal to, let's write in factored form. Negative 2 x squared, that's fine. X squared minus 9, that's the difference of squares. It's x plus 3, x minus 3. Okay, no removable discontinuities we're looking at here. So nothing to worry about there. Okay, let's go ahead and write our vertical asymptotes first. Y equals, x equals to negative 3 and x equals to positive 3. That's what makes these parts 0, right? The denominator 0. Horizontal asymptote. This one's a little more interesting. Okay, for the horizontal asymptote, I'm actually going to look at my original equation over here and look at my leading term, my x squared term. There's a negative 2 in front of that first one, and there's just a regular x squared term for the second one, which means it's a 1, right? Okay, so coming back here, that means my horizontal asymptote should be y equals to negative 2 over 1, which is just negative 2. All right, let's do our x and y intercepts as well. So starting with x-intercepts, that's when y equal to 0. And okay, another nice thing happens here, right? Where if I look at y equal to 0, that means 0 is equal to negative 2x squared. And I'm going to just go ahead and go straight to ignoring the denominator, because if I multiply that by both sides of the equation by this denominator, because this is 0, it disappears, right? So I've got negative 2x squared equal to 0. That means x is equal to 0. So once again, I have that nice, easy point, 0, 0. That's both my x and y intercept. I'm not going to bother writing the y-intercept part because I just found it. 0, 0 is both. If I was to plug in x as 0, then y pops out as 0 as well. Okay, here's my graph. Here's x, here's y axes. Let's do our asymptotes first at negative 3. So 1, 2, 3. Boom, right there. And then positive 3. 1, 2, 3. Okay. Okay, so something interesting here. I feel a potential for symmetry because the two asymptotes are exactly evenly spaced from the center. So maybe we should do a quick check. Symmetry. Symmetry? Let's see. So if I was to plug in f of negative x, what would happen? I'd have negative 2 negative x squared. Like I said, this is, like I mentioned before, this is an optional thing, yeah? Okay, interesting. So that's what I would get if I plugged it in, right? Of course, negative x squared, that's still going to be positive x. So that's negative 2x squared, same thing. And then the bottom, negative x plus 3, I could rearrange that to say, factor negative outside, and I have x minus 3. And here, negative x minus 3, I could factor a negative outside and have x plus 3. Now, negative times negative, those guys cancel. So I'm just going to erase them. And what am I left with? I'm left with x minus 3, x plus 3 in the bottom. Note that that matches exactly, right? So here, in fact, I do have symmetry. That's something to just keep in mind in the background. But you know what? Watch, when I graph, it won't have even matter. I could go by my business as if I didn't know there was symmetry and find out at the end there was in fact symmetry. But you know, symmetry is something that we talked about in the first chapter. That should be something that we're aware of. This is an even function, that kind of thing, right? We should be aware of that. Okay, so anyway, this graph is saying we got that one intercept right there, right? Okay, because it's symmetric, I know it's not going to do something like this. It must be doing something like this or like this. But either way, check test points. Here, the obvious one is negative 1, positive 1, and then here, positive 4 and negative 4. Just to know whether I'm above or below each of those spots. Okay, so... Oh, I'm sorry, I forgot to do my horizontal asymptote, which is at negative 2. So 1, 2, got the horizontal asymptote there. And I do want to know, too, if it crosses that horizontal asymptote ever. So how would I know that? Well, check it at y equal to 2 is their solution. So is 2 equal to negative 2 x squared over x plus 3, x minus 3. Does that have a solution? Okay, so how do I solve that? Okay, multiply both sides by x plus 3, x minus 3. I'm going to get 2 x plus 3, x plus 3, x minus 3. I'm going to go ahead and multiply that out. Or you can return back to where you started in this original equation, yeah? Okay, why am I doing this, guys? I'm doing this because I want to know whether or not I cross the horizontal asymptote at negative 2. And to figure that out, I got to plug in negative 2. That should be negative 2, sorry. I plug in negative 2 to find out if there's any solution where my function will touch negative 2. Okay, so looking at this thing, nice thing happens because, look, I've got two negative 2's on both sides of the equation, right? So I can just get rid of them. Just cancel them out. Oh, that's actually making things worse because it's red. So I should change my highlighter color to red. Okay, that is not helping. That was a bad idea. Okay, let's just erase. And let's just go back to this thing. Cross it out. Okay, so the negative 2's cancel each other out, right? And so what am I left with? X squared minus 9 is equal to x squared. Okay. Now, I'm going to subtract x squared from both sides. And if I do that, then this disappears. I've got negative 9 equal to 0, which has no solution. That's not true. That means I don't cross the horizontal asymptote. Okay, good to know. So no crosses of the horizontal asymptote. Now let's go ahead and check our test points. Okay, what are my test points? Negative 4, so I'm going to f of negative 4. And once again, I'm not concerned about, I'm not really too concerned about, what was I going to say now? Yeah, I'm not too concerned about what the values are exactly. I just want to know whether they're, well, I take it back. I kind of want to know where they are in relation to the horizontal asymptote actually. So I should find out the values. Okay, f of negative 4, that would be negative 2, negative 4 squared over negative 4 plus 3, negative 4 minus 3. Okay, that's negative 2 on the top times 4 squared is 16. The bottom, negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. Which is negative 32 on the top. The bottom is positive 7. So this is looking like, okay, that's negative 32 over 7. 7 goes to 32 4 times. So negative 4 and 4/7. Okay. So anyways, it's negative 4 and change, right? So where does that put me in terms of my graph? That puts me below the horizontal asymptote of negative 2, right? So, okay, main thing to know is that you're below somewhere, or about here somewhere. Yeah. Okay, that's not totally accurate. I just kind of estimated the distance there. But somewhere below the horizontal asymptote. Negative 4 is definitely below the horizontal asymptote of negative 2. Okay. So, actually good news. It does pay off that I did that symmetry check earlier now that I think about it, because I know now this is also a point, right? It should have a partner point. So I got a good idea of the graph now. It's going to approach that horizontal asymptote. It's going to approach the vertical asymptote. Something like that. Now, if you don't believe this point here, you can actually just check f of positive 4, but you'll see that you're getting it with the same thing. And if I think about it, that makes sense, right? Because if you plug in 4, you're going to have 4 minus 3 is 1. And then here, 4 plus 3 is going to be 7. And the top is still going to be that same 32, negative 32. Okay, so that's good. And then the top, I know I'm at this position here, and I also know that it doesn't cross twice. So I actually kind of know what's going to happen already, because it's not crossing this horizontal asymptote. I checked that already. So that means it must just kind of look like this. Hit that single point, come back up. Sort of like looks something similar to a parabola there. So I actually know already. How do I know? Well, I know because just recapping, because I know I checked earlier that it don't cross this horizontal asymptote. So there's no way for me to go down this way towards those vertical asymptotes. And I also know that this is the only spot where I touch the x-axis. So I can't go down and come back up. Yeah, if you want to be thorough, you can check those points. Let's just check f of negative 1. That would be negative 2 times negative 1 squared over... Oh, let's use this version, the x squared minus 9 version. That's actually easier, I think. Negative 1 squared minus 9. Negative 2, that's negative 2 times positive 1 over positive 1 times negative 9, which is 2/9, yeah. And then if I switch that to plugging in a positive 1 instead, positive 1, I get the same result, 2/9. So either way, I'm at 2/9. So here, 2/9, 2/9, yeah. And great, there it is. So kind of just confirmed what my graph is. And just for my own satisfaction, I do want to just compare my graph with the right graph. So negative 2x squared, negative 2x squared, that's on the top. The bottom is, what is it? X squared minus 9. Okay, you notice this time I have the negative out to the front, but it doesn't actually make a difference here. Or does it? What? Okay, wait a minute. Okay, I'm seeing that I was actually wrong here. Negative 2x squared over x squared minus 9. Oops, sorry. Oh, no. No, wait, I forgot the squared here. Oh, okay, woo! Scared myself for a second there. Yeah, there we go. Okay. I was like, oh man, we got to shoot this thing again. Okay, x equal to -3 is one asymptote, and then x equal to +3 is the other asymptote, yeah? So see how that lines up with my graph here? Yeah. Crosses right there at the center, goes up. And let's plot our horizontal asymptote as well. That's y equal to -2, yeah? See? Oh, look at that. So see how the blue lines approach that black line, that horizontal asymptote, but they technically never cross. See? Even if you zoom out way to where it looks like it's gonna cross, as long as I zoom in far enough, you see it's actually not touching, it's just getting closer and closer. So there you go. Hey guys, see you in the next one.